Hi everyone, so I'm going to be going over number 11 from page 194 in the Big Ideas Algebra 2 book. But this is actually solving a polynomial equation. So in looking at it, I look at the degree and I see the highest degree is 3. That tells me a little bit about what I should try and do. So there are several methods you could use here, but I decided to get everything to one side and see if I could use factoring. So I brought the n cubed to the left so it would be positive, and I wrote it in standard form. Okay, so you have a couple options here. You could first see if it's something that you could factor. So you could group together this and this. And see if it's something that you could factor, which you actually can't. So you would actually have to use the rational root theorem, okay? So we would use the rational root theorem. To see if I can get a depressed polynomial that might be factorable, right? So I'm going to take all the factors of 1 and all the factors of 64. So I've got the p over q and plus minus. So I'm going to have a plus or minus. So I have 1 and 64. Yes, it's a pain. 2 and 32. 4 and 16 and 8 and 8. Sorry, got those out of the way. And those are all going to be over 1. So each one of those is a factor. So I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32, and plus or minus 64. Okay, so then I have to decide which one I'm going to use. And like I told you, I'm going to allow you to use your calculator to find one of the roots. And so hopefully I found that -4 was one of the roots. So I'm going to use synthetic division with -4. So I'm going to take all of my coefficients. And then I'm going to add down. So we're going to get -32. I think that gives me 16. Yep. -64, and I get 0. Now I should get 0 right because I used my calculator and identified this as a root. But now I have a depressed polynomial. Remember, we go down 1 degree, so this would give me n squared plus 8n plus 16. And so that is factorable. Actually, it's a perfect square trinomial. So it's going to be n plus 4 squared. And so we can see that n is going to be equal to -4. All right, so that's telling me something, right? That's telling me that I have one factor of degree 3, right? Because we already knew it was -4, and then I have another one of -4. So that means that at -4, I have a multiplicity of 3, so my graph should actually be going through it something like that. So you might want to check and see if that's what it does, right? So, so my answer would be -4, -4, and -4. You could write it just once and say it's a triple root. Okay? Hopefully that was helpful. There are other ways to do this. We just haven't learned how to do them yet. There's a way to factor using the sum of cubes. You could actually put both parts into your calculator and see where they intersect. So there's lots of other ways for you to do this, but we've been learning about the rational root theorem, so that's what I wanted you to use. All right, hopefully that was helpful. Have a great day.